225,000 tonnes of iron ore in its holds, a carrier leaves Port Hedland on Western Australia's Pilbara coast, bound for the steel markets of the world. And as this journey begins, so too does another, 426 kilometres away, at BHP Billiton iron ores mine at Mount Whaleback. Every day, 365 days a year, up to 12 iron ore trains a day travel to Port Hedland. Each train weighs up to 45,000 tonnes, more than the entire weight of the Sydney Harbour Bridge's steel arch. Leading BHP Iron Ore's railway fleet is the General Electric AC 6000 series locomotive. It is the most powerful diesel-electric powered locomotive in the world, producing 6,000 horsepower. BHP Billiton Iron Ore's mining operations at Mount Whaleback in Newman has been the centre of mining operations since 1969. This massive open-cut mine is supported by Jimblebar Mine and surrounding satellite ore bodies. Yandy and Mining Area C are additional rapidly developing mining areas, which are serviced by rail spur lines off the Newman main line. These trains operate in one of the world's harshest environments, where daytime temperatures regularly exceed 45 degrees Celsius. Severe weather conditions with heavy rains, lightning and cyclones are a constant threat. Despite these conditions, this train entered the Guinness Book of Records as the world's longest and heaviest, when on the 21st of June 2001, it left Yandy Junction for Port Hedland. Weighing 99,732 tonnes and 7.753 kilometres long, it was hauled by 8 6,000 horsepower locomotives, spaced at intervals of nearly 1 kilometre. 682 ore cars and one driver. At its top speed of 75 kilometres per hour, the train would have taken 6 minutes to travel past any given point. These trains vary in size between 1, 2 and 300 ore cars. This allows for greater flexibility at our mines. Hauling the ore cars are our locomotives. 8 General Electric AC 6000s, 40 General Electric 4000 horsepower -8s, and 20 General Motors 3000 horsepower SD40s. These locomotives are used in various configurations, depending on the number of ore cars in the train. All, however, are controlled by one driver, using radio signals transmitted from the lead locomotive to up to 4 remote mid-train power consists. Drivers receive some of their initial and subsequent training in the train driving simulator, a replica of the driver's cabin of a locomotive with its functions linked to the images of the actual route.
Wait, is that correct?
All train movements, indeed all railway operations, are controlled from this centralised traffic control centre, located at Port Hedland. Highly sophisticated computer hardware and digital communications provide train monitoring information and support a rail network signalling system, which uses solar energy as its primary source of power. Automatic Train Protection System is an onboard system that ensures that trains do not operate beyond their designated authority and relays information directly to drivers. Hot bearing detectors sense overheated wheels and bearings, while acoustic bearing technology is now installed to detect bearing faults. Any cone faults, roller faults, audible wheel flats, cup faults, looseness and noisy wheel sets on all cars passing the unit are analysed, and defects are reported automatically prior to any likely failure. Instrumented ore cars also provide data that is not only important for the safe operation of the trains, but also extend the life of the ore cars. These units measure and record more than a dozen vital functions, including vertical suspension travel, wheel rail acceleration, in-train forces, bearing temperature and brake pipe pressure. All rolling stock, vehicle and track mobile machinery maintenance and repair work is carried out at our workshops at Nelson Point. The workshops carry out a range of services from minor maintenance, such as oil changes and fueling, to major overhauls of mechanical and electrical components. Precise in-situ machining of locomotive wheel sets is performed by this underfloor lathe. Working together with cutting-edge technology, video imaging takes digital photographs of every wheel on every locomotive and car that enters the Nelson Point yard. Each video image is computer compared with the ideal wheel profile to measure their wear rate. Highly sophisticated, computerised equipment is used for the scheduled servicing of the more than 3,000 ore cars in the rail fleet, as well as for detecting and repairing any faults. 37 individual components on each ore car are tracked and monitored for the life of the equipment. The benefit has been a six-fold increase in the wheel life per million tonne kilometres since 1980. 3 track maintenance crews based in Port Hedland, Newman and at the Redmont Track Centre some 200 kilometres south of Port Hedland ensure the line remains operational and safe at all times. Daily visual inspections combined with weekly ultrasonic inspection are used to detect rail defects. Should a rail defect occur, this is repaired effectively and quickly using an in-track flash butt welder. BHP Billiton Iron Ore Railway is a world leader in heavy haul railway technology, the result of a continuous research and development program over the past 25 years. This emphasis on research, together with a history of innovation, commitment to continuous improvement and focus on safety, has seen its productivity, measured in million tonnes railed per employee, triple over the past decade. Keeping our railway is a huge and demanding job. We have a team of dedicated, highly trained BHP Billiton iron ore people, supported by local expertise, that keeps the wheels turning. That's why, when it comes to moving mountains to markets, nobody does it better.